welcome back to our course on procedural programming. As you see, we're back in the middle of Unit 2. As you have already seen, there is two different sessions on Unit 2. The first session, which is already covered in another video, shows the basic work with UNIX shell. And now the second session we're dealing here in this video is about writing your first C program. So let's have a look into the particular goals we want to accomplish in this video. The first one is that you should write your first C program. Well, the program itself will not be the really big news. First of all, it is much too tiny to cover big surprises, and second, it will be, as you're already familiar with C#, it will show a good number of similarities to other programs you have already written in C#. Second goal is that, well, we repeat the steps how to come from a source code to machine code, because building your first C program, this will be more on the new side on this video. So because building C# programs is highly supported by an IDE, Visual Studio, or if you're working on another system, Xamarin Studio or some other IDE. And these programs, these integrated development environments, are hiding all the small intermediate steps when you build a program. So, and here, since we want to look a little bit behind the curtain, we're now going into detail and check out the smaller steps, and we will see how building a C program really works. And finally, of course, you should start then your first C program and see that it really does what it is intended to do. Alright, now, ta-da, this is the program, and you can see, well, here some comment having some basic information about the program, and you as an author and stuff like that. You see comments are as they are in C#. And well, the next line, this is new to you, but also shouldn't be a big problem to understand at first hand. It is, we include something which makes us able to print something. This is standard I/O, so means input and output stuff. We include so a header file to be able to do input and output. Here, this line, this is the main function. It is quite similar. You maybe know that there is a method main in C#. There is only the difference that main is written with uppercase M, and we have here some arguments we don't care too much about for the time being. We'll go into this in a later unit. Then we have the curly braces, similar or very the same as in C#. Then we have one statement here, printf. This is comes from this so-called library, so say more it's a header file, but okay. And so we're writing hello world, and we are adding a new line character at the end, and then we return 0. We have to return something because the main is returning an int. Well, That's it. Not too difficult, and should be well understandable, I think. So now the really interesting thing is, how can we make this run? And well, just to remind you, source code can't be executed directly on a computer. There is no instruction set that is able to execute C or C sharp source code. We need some translation. Uh, this we called in at the beginning, we simply called it compiling. It's more a build process, but okay, we'll see this anyway later on in this video. So anyway, we have to translate the source code into target code or machine code. And well, in former times, we did this by using IDEs. So last year in C Sharp, we used Visual Studio to make our C Sharp programs run. This would be also possible in C, but well, we are. This is not always the case. So especially if it comes to C, you have sometimes not these comfortable development environments as Visual Studio or NetBeans or IntelliJ providing. So then we have to go back to simpler tools, and we will look into this one now. Good. Just a small repetition. We did it already in other courses. How do we come from source code to a running program? Means from source code to code that is executable on a machine. And well, we start out with source code here. This is, so we call it as an example, hello underscore world dot c. This is the source code. This is a file as we have already seen before. And then we're going through a compiler which generates another file, basically a hello world.o, which is the target code or machine code reflecting the functionality we have written down in the source code hello world.c. As a next step, we're going through a linker which then generates another file, and this is hello world in our example, and this is the executable program, and this is again written in machine code. There is just there is one difference between here and here, that some addresses of external functions and stuff like this is resolved in here. In this file, there are some unresolved addresses and stuff. So this would not be runnable. It's basically machine code, but wouldn't be runnable. And the linker is then inserting addresses of external references. So from here to here, we need these two steps at least. There are more complicated build environments, but this is so we will not consider this now. In the simplest case, this happens if you are trying to run a source program, or to make out of a source program, a source file, a runnable program. And in general, the whole thing between the source and the runnable program is called the build process. Okay, now how do we do this for a C program in the UNIX shell. Okay, we want to look behind the curtain. We could, of course, we could use an IDE, but we will not, since we want to see what is really going on. And we can do this in the shell by writing the following command: gcc minus wall minus pedantic minus std equals c99 minus o hello hello underscore world.c. Oh wow. So maybe have a small look into the different parts of that command. First of all, the GCC is the command. It stands for GNU Compiler Collection. This means that there is not only a C compiler, but there are some other compilers in. But if we feed in a C source, then we are then the GCC is compiling the C source into machine code. Then the next stuff here is a bunch of options I will explain later on. So we simply ignore them for the time being. And now the next one, the minus O hello. This is just to say the compiler what kind of executable, so what is the name of the executable. And hello world.c is simply the source file, the one file we want to build. As you see, this is one command for doing both things, compile as well as link. This is the simplest case. We would be able to split this up into two different commands to compile first and then link the files. We will do this in a maybe, I don't know, 1 or 2 months time, when we're already familiar with that, because if we have more than one source file, then we have to split this up into 2 steps. But for the time being and for now, it should be pretty fine to use simply this one command to both compile and link a C source file. Well, and finally, if we are now here and we have a file compiled and linked, and we have one executable, and as we said here, it should have the name hello, we can start this program by typing in the shell ./hello. This means that here this ./ means that hello, the command hello, is located in the current working directory. This is simply, there is one reason for this. All the commands have to be found somehow by the computer system. And if you have a command like this one here, this is a general command for the whole system, and it is located where a search path is pointing to. But our command we just generated here is not in a general search path, and so we have to explicitly state where this program resides, and we say, okay, it's in our current working directory. Maybe you remember from last session that dot is referring to the current working directory, whereas dot is working to is pointing to the parent directory of our current directory. Have a look finally into these options where we said before that we want to ignore them for the first time, and then we'll go into the shell and see how this really works. But okay, first the options in a more detail. The first option, minus wall, turns on the most important warnings. Most important is a bit fuzzy here. we just take it as these warnings which we need since we want to take warnings seriously. Warnings is a really important topic insofar as if we ignore warnings during the compilation process, then we run into danger that we are generating some kind of hidden errors which are very difficult to be traced down and during runtime. So we really take care of warnings, and we want to have as many as possible, and we want to eliminate all the source parts which generate warnings, and so that's why we are turning on all or the most important warnings. You wanna know what what kind of warnings are all behind this minus W all. You could simply refer and check out GNU, the GCC website, where you have a list of all the warnings in detail, which are then reported. The minus pedantic is pointing to a similar direction. It issues all the warnings demanded by strict ISO C. Here it may be interesting. What is ISO? ISO is the International Standard Organization, which is in charge to define standards for C. This means that C is a language which is following some standards, and this is necessary since there are many different vendors and suppliers of C compilers, and to have C source to be compatible over different compilers and platforms. C is standardized, and compiler vendors or implementers are urged to follow these standards. Well, and also the last warning, the last option is about standards, and this means we are requiring the C99 standard, which is the standard issued by ISO in the year 1999, which looks a little bit antique now, but actually there is just one newer standard, and this is C11. But the C11 doesn't really bring us too many things which are important for our work here during this course, so we can stay at the C99. If you like, you can also state here the C11, and then you would compile following the C11 standard. It would not make too many differences. Yeah, now we go to the shell and see how this feels like if we're working then in the shell and trying to compile that. So we start by editing our source file. This one we start gedit, the editor you have available on your systems, and I will use it now to show you how it works with gedit. And yeah, okay, we say hello world.c. Okay, just to repeat, gedit is the command to invoke the editor. Hello world.c is the file we want to create, and this ampersand here is to have the shell responsive after invoking the command. otherwise it would get stuck. The shell itself would get stuck and we would not be able to type in any further commands. So return, you get the number here. Oops, sorry. You get the number here. This is the process number of the gedit command. Yes, and so you see here we have hello world.c. We have the document opened in gedit, and now we can start typing in our program. You remember it starts with some command describing the program, etc. I don't want to bore you with that. So we just go to the important things, to the technical things, and you maybe remember we said include standard.io.h, the header file, which enables us to do input and output. We need it then for the print command. Yeah. So hash include is the directive to include an external library. We can understand it like this. Yes, and then the main function has to be written down. In C, the main function returns a value, an int value. Then we have main, main, and then we have these two arguments where we said that we don't bother too much up to now. So character argument vector. Okay, sorry. Here we have to change. This is not necessary on your systems, but okay, this just to make me able to state these braces. Okay, curly braces. Okay, and here comes the content, and this is simple printf hello world and the new line character to start a new line after we have printed hello world, and then we say we return a value, and since everything is fine, we return a 0. This is a convention. Just simply take this over. We will talk about this in a later unit, how this and why we do return 0 here. Okay, this is our C program. It's pretty simple. So we save it. Zip. And if we look into here, we can ls, and we see hello underscore world.c. This is the program we have written. We can check it with less. Oops, sorry. Okay, here we are, and you see this is the program here, and we did it correctly. Okay, and now we can start to build that program. You know, we have to state the command to make an executable file, and this is the gcc, and then we have this fine options minus w all minus pedantic minus standard equals c99 minus o hello. This will be the name of the executable file then, and we say we want to compile hello world.c. We want to compile and link hello world.c. Return. Takes a bit to invoke the compiler, but here we are done. We have no message from the compiler and from the linker. This is good news. So we can check with ls, and we see we have an executable file here. So if you if you invoke ls minus l with the option minus l, you see a little bit more details. You see here hello world.c. This is the source file, and the executable file hello, and you can see here there are these x here and here and here, and this means this file is an executable file. Okay, since it is executable, we can invoke it dot slash to say it is in our hello resides in our working directory, and hello return, and it says hello world. Not a big surprise since we've done it here, but you can check it. You can enter your name, save it again, invoke the GCC to compile and link the program again, and then we invoke hello, and it says hello Peter, as expected. Okay, this is the was the demonstration. Now we go back to our presentation and just have a small recap what we did. We have written our first C program. You see here again, pretty small, but it's a C program. We were also discussing the steps from source file to an executable file via the build process, compiling and linking. And finally, we started, we built and we started our first C program, and we found out that it works. Okay, I hope that this was helpful for you, and see you soon when we are starting with Unit 3.